Standard form. Let's learn about the third and final form we need to learn for graphing lines. The essential question today is how can an equation be written using multiple representations? And here's what I mean by that. We know three forms so far, right? We know slope-intercept form, y equals mx plus b. The m told us slope, the b told us y-intercept. Those were very useful things. We know how to solve for them. We could plot them on a graph. Very helpful. Point slope form. Also very helpful, y minus y1 equals m times x minus x1. Again, very useful. The m represented the slope. This x1, y1 represented a point. x1, y1, a point on the graph. And again, we could graph this. Very, very nice. Standard form, my least favorite form because it gives us the least important things. ax plus by equals c. Does the a, b, and c tell me anything directly like it told me in these two equations? No. Can I solve for anything directly using nice little formulas like the slope formula, or by looking on the graph to look at the y-intercept, or by finding a point on the graph? No. So why does it even exist? It's not super useful for us, but it exists because oftentimes when we make an equation, the x and the y end up being on the same side. Also, we've seen this equation before when we did intercepts methods, and if you don't remember what that is, I'll be getting it into this video, so it might be a nice review of a couple different things with lines. Let's look at example number 1. We want to convert this line, y minus 4 equals negative 2 times x plus 3, to various different forms and graph. And what I'm hoping to show you is that all of these different forms, they all are going to end up with the same graph. Now, hopefully you understand that this right now is in point slope form. Point slope form tells us a point, negative 3, 4, remember they're kind of lying to you, and it tells me a slope, negative 2. Very useful pieces of information. I can put it on the graph. We can graph the point negative 3, 4, and then from there we can go down 2 over 1, down 2 over 1, and we can make our line. Very nice. All right, but my problem is asking me, hey, can you convert to various different forms for me, please? Here's how I'm going to do that. What I can do is I can just straight up manipulate the equation. Here's what I mean by that. Remember, if I'm trying to get to y equals mx plus b, so let's go to slope-intercept form first. The key feature of slope-intercept form is that the y is by itself. I have isolated the y. That's the key feature. So let's take a look at this equation and see if we can isolate the y. I guess the first thing I would want to do is distribute, because does slope-intercept form have parentheses in it? No, it's just y equals mx plus b. So let's distribute. That'll be negative 2x minus 6. And then to isolate the y, I just need to add 4 to the other side. So I have y equals negative 2x minus 2. Sweet, so we just went from point slope form to slope-intercept form. And remember, the way to get to slope-intercept form is just to isolate the y. We've done that before, right? Here, the negative 2 is my slope. This negative 2 is my b, my y-intercept. Let's plot the graph of this as we would graph it in slope-intercept form. Okay, so the y-intercept is negative 2. And then the slope is down 2 over 2, down 2 over 2, down 2 over 2, up 2, left 2. Hey, is this the same line? Yeah, it is. It's the exact same line, except I graphed it in a different way. Now that's pretty cool, right? I think it's cool because I'm a math teacher. We have two different equations. They mean the exact same thing. Now, let's look at the key feature of standard form. The key feature of slope-intercept was having a y by itself. Here's the key feature of standard form. Remember I said this a, b, and c don't really do anything for us? But the key feature of standard form is that the x and the y, they need to be on the same side. C, kind of a constant value without a variable, needs to be on the other side. A, b, and c are just numbers. So to put this into standard form, all I need to do is get the x and the y on the same side. And how can I do that? Let's just add 2x to both sides. So I have 2x plus y equals -2. Hey, it's in standard form. Are x and y on the same side? Yeah, they are. Is the constant the number without the variable on the other side? You betcha. So this is in standard form. Now, how would we graph in standard form? Well, what we could do is we could convert back to slope-intercept form and do it that way. But remember, standard form is really well set up to do intercepts method. If I plug in a 0 for x, what would the y equal? Okay, so 2 times 0 is 0. Y would equal -2. What happens if I plug in a 0 for y? Then, in order to find the in order to find the x, I would divide by 2. Looks like x would equal -1. So that's intercept method, right? Do you remember that? I plug in 0 for each of the variables, find the intercepts. Let's look. Over 0 down 2, that's right there. Over -1 up 0, that's right there. And would you look at that? It's the exact same line. Very, very cool. So each of these forms tells us different things. Standard form is well set up to use intercepts method. And the key feature of it is having the x and the y on the same side. Slope-intercept form is well set up. It gives me the y-intercept and the slope. And its key feature is that it has y isolated. Point-slope form gives us a point and the slope. All right, let's do another example. Write the equation of a line that goes through the points 3, 9, and 1, 1 in standard form. So let's do it with two ways. First of all, let's get the slope first. We really need the slope, and that would be 9 minus 1 over 3 minus 1. That's going to be 8 over 2, which is 4. Now at this point, I can do one of two things. If I'm trying to get to standard form, remember, I can't really get there directly. The a, b, and the c aren't really things that I can find. But what I can do is I can find slope-intercept form first and then convert to standard form. So to find slope-intercept form, remember, I'm going to take one of these points. I'm trying to get y equals mx plus b. Let's take the point 1, 1 and plug it in for the x and the y. Let's plug in 4 for the m and solve for b. 4 times 1 is just 4, so I would subtract 4 and find that b equals -3. So my slope-intercept form would be y equals -3x. Sorry, the slope. Y equals 4x minus 3. Remember, all I have to do to get to standard form is put the x and the y on the same side. So I would subtract 4x and subtract 4x. And that would give me -4x plus y equals -3. This is in standard form because the x and the y are on the same side. And remember, standard form sets it up perfectly for me to use intercept method. But if I'm asking you to graph, do I really even need intercept methods? Do I really even need the slope and the y-intercept? Not really. Let's just graph these 2 points, right? Easy. Over 3 up 9, over 1 up 1. Here's 2 points. I can make the graph. Done. Solid. Keep in mind, though, my main objective was getting standard form. Keep in mind, the way I got standard form, I can't find it directly. I started with slope-intercept form. Then I just moved the x so that it was on the same side as the y. That put it in standard form. Awesome. And standard form is useful for intercepts method. There's just one semi-unrelated example I need to do with you, and that is this. What are the equations of the horizontal and the vertical lines through -5, 4? So let's plot this point. Over -5, up 4. I'll do the vertical line in green because green is trees and they grow tall. I will do the horizontal line in purple because purple people are dead and they are lying on the ground. So let's talk about the horizontal line first. Remember, the horizontal line, every single y coordinate is exactly the same, but the x coordinate can be anything. Since every single y coordinate is the same, what is that y coordinate? It's y equals 4. That's the equation of the line. It doesn't really follow a format like slope-intercept form or point-slope form. This is more like standard form. Because I have just a y, you could kind of imagine a 0x over here because, well, the x can be anything. And so whatever I plugged in, it doesn't matter because it's getting multiplied by 0. Anyway, we just write y equals 4, sort of like standard form. All right, now let's worry about the vertical line. Remember, with the vertical line, we are always having the same x-coordinate, but the y-coordinate is always changing. So x equals -5 always. The y, if you're putting it in standard form, would be multiplied by 0 because it doesn't show up, but also the y could be anything. If I'm multiplying by 0, it has no effect on the equation anyway. Anyway, if that didn't make sense to you, that's fine. The easiest way to think about this would just be x equals 5. Don't even worry about the 0y. X equals 5, equation of a vertical line. Y equals 4, equation of a horizontal line. Always for the horizontal, it's y. Always for the vertical, it's x. Summary, standard form, ax plus by equals c. Remember, what do the a, b, and c tell us? Nothing. So why is this form helpful for us? Well, because it helps us to graph an intercepts method, and we just see it often in life. So standard form, there you go. Thank you for watching.